Exercise 1.1 of Class 12 NCERT book. Questions on reflexive, symmetric, transitive, and equivalence relations. Check whether the relation are in set of real numbers defined by r is equal to a comma b such that a less than or equal to b cube is reflexive, symmetric, or transitive. This time, the set given to us is set of real numbers. All real numbers from minus infinity to plus infinity is the domain, same is the codomain. The condition given to choose the ordered pairs from the R cross R is A should be less than or equal to B cube. Any ordered pair AB will be included in the relation only if the first number is less than or equal to the cube of the second number. A is less than or equal to B cube. Let's see whether it is a reflexive relation. What is reflexive relation? Reflexive relation if A comma A belong to R for every element A of the set. For every real number. Every real number should be related to the same. Only then we can call this relation a reflexive relation. Let's check few of them to study the situation. Is it true that A less than or equal to A cube for all real numbers? Yet to be checked. Is it true that 3 is less than or equal to 3 cube? Yes, 3 is less than or equal to 27 is true. So, 3, 3 can be included in this relation. Is it true that 0 less than or equal to 0 cube? Yes, 0 less than or equal to 0 cube is 0. This also turns out to be true equation, true statement. So 0, 0 can also be included in this relation. Is it true that minus 2 less than or equal to minus 2 whole cube? Minus 2 cube is minus 8. Minus 2 and minus 8. No, minus 8 is lesser, not minus 2. This inequation goes false. So, minus 2 comma minus 2 cannot include in this relation. So, we got an example which goes against the definition of reflexivity. This example can be highlighted as a counter example. There may be many more pairs which cannot be included in the relation that are of the form A comma A. But we need to just highlight one example which counters the definition, which goes against the definition. Any of these can be written as counter example. Half is less than or equal to half cube also is not true. Half cube is 1 by 8. Half less than 1 by 8. No, not correct. Therefore, 0.5 comma 0.5, half comma half cannot be included in the relation. So, one element of this type fails to remain in the relation means this relation cannot be called reflexive relation. It's not a reflexive relation. Is it symmetric relation? What is symmetric relation? Whenever there is a pair A comma B that belongs to the relation, B comma A should also be there in the relation. Let's go on checking few of them to study the situation. 2 comma 10 belongs to R. Is it true? Let's check first of all. 2 less than or equal to 10 cube. For 2 comma 10 to belong to R, 2 should be less than or equal to 10 cube. 10 cube is 1000. So 2 less than or equal to 1000 is true. So this pair is there in the relation. But let's say 10 comma 2, the reverse one. Will it belong to the relation? Check. A is 10, B is 2. A is 10, B is 2. 10 less than or equal to 2 cube. 2 cube is only 8. 10 is not less than or equal to 8. Therefore, 10 comma 2 cannot belong to the relation. This is the reason. So we could get a pair A comma B that is there in the relation, but its reverse pair is not in the relation, not found in the relation. So this numerical example can be treated as a counter example. So this relation is not a symmetric relation. Now, is it transitive relation? What is transitive relation? Whenever the pairs of the form AB and BC are there in the relation, there should be A comma C also in the relation. Let's check. I'll take two elements, two pairs, 10, 3 and 3, 2 belonging to the relation. Let's first of all check whether they do really belong to the relation. 10, 3. A is 10, B is 3. 10 less than or equal to 3 cube. Well, good, correct. 10 is less than or equal to 27 is true. Then 3, 2. A is 3, B is 2. 3 less than or equal to 2 cube. Even that is true. Both of these pairs do belong to this relation, given relation. Now, these two are in the form AB, BC, where B is the common element 3 in them. Now, to call this relation a transitive relation, whenever such pair with this common two elements are there, this first element to the last one, A, C pair also should be there in the relation. Let's check whether 10, 2 will belong to the relation. 10, 2. 10, 2. A is 10, B is 2. A 10, B 2. 10 less than or equal to 2 cube is not true. So, this relation cannot be treated as a transitive relation. We highlight this numerical example as a counter example. Now, is it an equivalence relation? Not at all. A relation which is symmetric, reflexive, and transitive is called equivalence relation. This relation is none of them. So, this relation is not an equivalence relation.